All right, so 13.3 measures of relative position. So we started with what we're going to call the z-scores. So your z-scores, the number of standard deviations that a data value is above or below the mean. So notice we have right here, positive for when it's below. So when your z-score is positive, that means it's above the mean. When your z-score is negative, that means it's below the mean. Don't forget your means, it's another word for average. So it's the number of standard deviations that a data value is above the average or below the average. All right. So here's our formula. So don't forget, for the population versus the sample, we have different symbols that represent the same thing. We know that this is the mean. One is for the sample, one is for the population. And then this is our symbol for the standard deviation. So our general formula is right here. Basically, no matter what you're doing, no matter what type of data you're dealing with, whether it's the population or the sample, what you will always be doing is the data value minus the mean divided by the standard deviation. So that's always going to be the case. It's the data value minus the mean divided by the standard deviation. That's how you will calculate your z-scores. All right. Everybody good before we do this? All right, straight. All right, so let's look at our first example. If I scroll up too far, let me know. All right, so Raul has taken 2 tests. He scored 72 on the first test, for which the mean of all scores was 65. And then the standard deviation was 8. He received a 60 on the second test, for which the mean of all scores was 45 and the standard deviation was 12. In comparison to the other students, did Raul do better on the first test or the second test? So I'll give you a chance to write that down, and then we'll walk through it.
Hello. I was
Hey,
wondering, is this 13.4?
13.3.
Oh, 13.3. Okay.
Mm-hmm.
I already finished the homework for 13.3.
Mm-hmm.
Okay, just making sure.
Yeah, that's fine. That's fine.
I just need help with 13.4.
Okay, yeah, so we're actually doing 13.4 next class. If you talk about lecture.
Oh,
Yep,
yeah, the
yep.
lecture.
Mm-hmm.
Because
Now
I
I
wanted
can
to.
send you the lecture from, if you just want to get ahead, I can send you the lecture from last class. I mean last semester if you just want it.
Yeah, I'll have that lecture for 13.4. Yeah.
Yeah, I think you emailed me about something recently, haven't you?
Yeah, I did. I did.
Is it Campbell?
Yeah, Campbell.
Yeah. So
I found. Yeah.
I'll send you that sometime today.
Okay. Thank you. I appreciate it. Because
Not a
I
problem.
already knew. I found the answer for 13.1.
Okay, okay, gotcha,
Yeah.
gotcha. Yep, yep. I'll send that to you before the day is out. All right. So here we have 2 sets of data. We have the data for test 1, wherein Raul scored a 72. Then we have the average and the standard deviation. Then we have the data for test 2, where he scored a 60 with the average of 45 and 12, talking about from the class. So gather that data. So we see our first set of data. The average for the class was 65 with a standard deviation of 8, but he scored a 72. So we put that in the z-score formula. That'd be 72 minus 65 divided by 8. Give us 0.875. Second test, he scored a 60, but the average of the class was 45, standard deviation was 12, and that gave us 1.25. All right, so the conclusion from that, on the first test, he scored 0.875 standard deviations above the mean. On the second test, he scored 1.25 standard deviations above the mean. So in comparison to his classmates, he did better on the second test. Any questions? Any questions? All right. So looking at the next one, a consumer group tested a sample of 100 light bulbs and found that the mean life expectancy of the bulbs was 842 hours with standard deviation of 90. One particular bulb of the company from the company had a z-score of 1.2. What was the lifespan of this bulb? All right, so write down the information that you have. Try to figure out what it is that they want you to look for. So they gave us our mean of 842, standard deviation of 90. And then this time they gave us the z-score. Notice it says the z-score is 1.2. And they want us to find the data value that corresponds to that z-score. So you plug it into the z-score formula and then solve for the piece that we are missing. So that's 1.2 equal to x minus 842 over 90. Now to solve for x, we'll multiply both sides by 90. So the 90s will cancel out on the right. And let me erase this. And that'll leave us with 108 because 90 times 1.2 is 108. Equal to x minus 842. Now to finish solving for x, we will add 842 to both sides. And that'll give us 950. Any problems with that? So that means that the light bulb has a life expectancy of 950 hours. Any problems with that before we go to the percentile? Percentile. All right, so the Pth percentile, that's just the percentage of data that is less than the given value. So many example of that. If the baby's weight is in the 85th percentile of the United States or the US, that means that 85% of babies in the US weigh less than that baby. And then 15% of the babies in the US will weigh more than the baby. And so you get 15 from subtracting that 85 from 100. All right, questions on that? All right, so finding the percentile of a given value. So the percentile of score X is the number of data values less than X over the total number of data values times 100. All right, so on an exam given to 900 students, Elaine's score of 602 was higher than the scores of 576 of the students who took the exam. What is the percentile for her score? Probably could have read that better, but you all right. Where is that? Okay. All right, so I was looking for a chart that I'm gonna have to send you guys for 13.4. So while I was thinking about it. All right, so to calculate the percentile, I lost my pen. All right, there we go. So to calculate the percentile, take the number of data values that are less than the score, place it over the total number of data values. So it's 576 over the 900. And then multiply that by 100 will give you 64. So her score of 602 places her at the 64th percentile. All right. Any problems with the percentile? All right. Next thing on the list is quartiles. Data values that split the data set into fourths will be our quartiles. So we have our minimum and maximum value as bookends, smallest value, largest value, and then in there we see quartile 1, 2, and 3, and they help split our data into fourths. All right, so the way we will find our quartiles, first we'll list our data values from least to greatest. Make sure you don't forget that first step. A lot of times people miss that first step, and that's where they come up short. So make sure you're careful on that. And then from there, we will find quartile 2 first. So that's the median, the middle data value of the whole set. So you find quartile 2 first, and we talked about finding your medians. Your medians are just your middle values. If you have an odd number of data values, you're just going to have that middle value, which will be your quartile or Q2. But if you have an even number of data values, you take the two middle values, add them together, divide by 2. So remember we talked about finding your medians before. Q2 is the first one we'll find. Q1 will be the second one because that's going to be the middle value of your first half of data. And then Q3 will be the middle value of your second half of data. All right. Questions? Any questions? All right. So let's go ahead and do this. Now I wrote these data values this way. I went ahead and wrote them in order. Oh, let me erase that one. And I split them up that way so that I had my middle value just sitting here in the middle. But I have 25 data values altogether. See that right here. And so since I have an odd number of data values, I do have this middle value, which is 43. So I split my data in half as I was writing it, just for visual purposes. Of course, you wouldn't get your data set like this. You would get them probably mixed up, and then you have to rearrange them in order. So I already had them listed in order. All right. So like I said, that's always your first move. All right, so after you list your data values in order, you find Q2. Now I have an odd number of data values. That means I actually have a middle value, and that's going to be 43. That is Q2. My middle value splits my data into half. Now if I have 25 data values and I split it in half, that means I have 12 values up top as my first half of data, 12 values down bottom as my second half. So that means I have an even number. I need to take the two middle values, add them together, divide by 2 to find Q1. And that's what I did down here. Remember, Q1, Q2, and Q3 are just medians. They're just middle values. Q2 is the middle value of the whole set of data. Q1 will be the middle value of your first half of data. Q3 will be the middle value of your second half of data. So 39 plus 39 divided by 2, of course, will be 39. And then 50 plus 53 is 103. Divide that by 2 is 51.5 for Q3. Right. Questions? Any questions? Make sure we're good on everything I've said up to this point. Oh, someone said something in chat. Oh, we see good. Okay, cool. All right. Next thing, box and whisker plot or box plot. It's going to be a tool that we will use that provides a visual summary of a set of data. Notice how it's set up. You have a box with 3 lines that will represent Q1, Q2, and Q3. Then you have these lines that extend from the box, and they extend out to your minimum value and your maximum value. Those are called whiskers. All right, so if I were to take that and transpose that from the information that we just got from the last example, our smallest value is 26, our largest value is 23, and then Q1 was 39, Q2 was 43, Q3 was 51.5. All right, questions? Any questions? All right. Next thing might be the last thing. Stem and leaf plot or stem and leaf diagrams. So your leaf is going to be the rightmost digit of a data value, and your stem will be all of the data value, all of the digits, excuse me, that precede the leaf. So if you look at the number 25, 5 will be your leaf, that's your rightmost digit, and then 2 would be the stem. You have the number 173, the 3 would be your leaf, which is your rightmost digit, and then 17 would be your stem. All right. Erase this stuff. All right, so we're going to construct a stem and leaf diagram with this data set, 65, 72, 96, 86, and that's a 43, 61, and all the way down the line. All right, so first thing we want to do is identify the smallest and largest value, and that's what I did with the circles. Circle 43, that's our minimum. 98 is our maximum. So we notice that we're going from the 40s to the 90s. We have 43 to 98. So we're going for from the 40s to the 90s as far as our data set is concerned. Then we can set up our stem leaf chart. Let me erase this stuff. Okay, it's not erasing. There we go. So our stems are going to go, like I said, from 40s to 90s. So we got 4, 5, 6, 7, 8, 9. So that's what helped me establish the beginning and end of the stem over here. And our leaves will be that rightmost digit for each data value that we see. So our smallest value was 43. So we have a 3 that will go here. I think there's another 40, and we got 49. All right, so it's 43, 49. Now there are no 50s. So what you do not do is put a 0 here because that represents the number 50. You would just leave it blank and then go to the 60s. And you normally try to be in order. So you got 61, see 65, 68. And we're looking at our 70s. Let's see 72, 73, 74, 75, twice, and 78. Go to your 80s. I see 85, 86, 1, 2, actually 86 3 times. Oh, I missed 84. Normally you put that in order, but you know, we'll be all right. Just doing our, you know, the visual right now. And that's it for 80s. And then 90s, we have 96 and 98. 96, 98. All right. So questions on how you do the stem leaf plot. So everybody okay with what we did there? All right, questions. Everybody good? Everybody straight? I think that is it for 13.3. Before I go any further, anywhere else, any questions on anything I've said up to this point? Everybody good? All right. So we have one more section to cover. That's 13.4. Like I said, we'll do that next class. And as far as new material is concerned, that is it for us. So from that point forward, we'll be looking, you know, just to review, answer questions. You know, you guys bring them to class so we can knock them out. And make sure you're straight going into your final. At some point, I don't think I posted the final exam review, but our final exam is that first week in May. I think I just saw the schedule. Was that the second week in May?
So we won't be starting our final exam next week?
Oh no, I can't
Or we
do it
still
like.
have more to go?
Yeah, well, we got 13.4 to do, and then after that, we just make. You know, I won't say legally, but I'm really not supposed to enforce taking the final exam that early. You know what I mean? So
Okay.
I'm really supposed to actually wait for final exam week, because if I enforce it early, then people would be like, well, I had, you know, this much time left in the class to do the stuff. So, and I wouldn't want to do that to anybody anyway, because, you know, give people the amount of time as possible to study for it and get right for it.
Okay.
So final exam week is actually the week of May 10th. So that's our second
Would
week in May.
Will there be a pre-test for the final exam?
What you mean, like a final exam review?
Yeah, review.
Yep, yep, I'm gonna post that. And so
Okay.
you'll have
And
something
so
to study.
after, when we're done with our lecture notes and the exam for these lecture notes, do we just wait until the final exam in May? Do
Yeah,
we have any other work after, or this is
well,
just it?
yeah, I'm not gonna do that to you guys. I mean, I know some instructors that would, you know, as far as, you know, we finished early, let me find something else for y'all to do. No, I'm just gonna yeah, for those who are finished and actually ready, yeah, you just have to wait till final exam week. Yep, yep,
Okay,
yep,
thank you.
yep.
Because some of my professors are doing some of that, and I'm like, come on now.
Yeah, I don't think it's right, because
Because, right.
for what? Like, why am I making extra work? I don't see a reason for it. So I think y'all will be straight. So that's just the benefit to being on top of things. You got stuff knocked out, then you just chill for a minute and wait for this final exam.
And
Yeah.
we still go to the classes work, or are we just, so how's that going to
Well,
work?
nah, if you finished, you can just check in every now and then. But nah, I wouldn't make you come to a class if you're done. I mean, unless you
Okay.
just want to come, shoot the breeze. I mean, I don't like to hold people hostage, man. So I'm not really down for that. So yeah, you
Right.
can just email me every now and then. Just make sure you didn't miss anything. I mean, if you've done the work, I don't see a reason to make you come to class.
And also, will there be extra credit? Like if you say you got like a B, can you bring it up to like an A?
Well, I would say make sure you've exhausted all of your possibilities first, because you do have built-in extra credit when it comes to, if you know, the certain tests were like 104 points, 105 points, and stuff like that. So you have extra credit built into some of your tests. And then for your test reviews, remember, if you get 85 or better on your test reviews, then you get 5 points added to your test as well.
Okay.
Um, so what I would do though is, you email me to let me assess where you are actually after you submitted everything, to see if it's even worth you doing. You might already have the grade that you're looking for. You know what I mean? So,
Probably.
yeah,
Or you
yeah,
probably had an
yeah, yeah. So you
A.
just email me, and I can let you know what I see as far as your grade is concerned.
Okay. Thank you. Appreciate it.
Yep, not a
So
problem.
do we leave or should we just stay on real quick? We
Right
still,
now?
yeah.
Oh no, I'm about to close out. I was just seeing if anybody else had
Oh,
any questions
okay.
about anything, and
Thank you,
then
Professor.
we good to go. Say again, sir.
Okay.
Thank you, Professor. Appreciate you.
Yeah, not a problem, sir. Not a problem.
Appreciate you too. Have a blessed day.
All right, thanks. You do the same. Anybody else before we close? Everybody good?
I should be good. If I have any questions, then I'll just let you know next class period. Oh, and I'll send you the email about the quantitative reasoning.
Yeah, yeah.
Will those be like the same questions on there? Do you know yet or no?
You told me if I were to reset it?
Yeah.
Yeah, it should be the same ones. Yeah, it doesn't
Okay.
generate new questions. Yep.
Okay.
All right. So you
Oh, wait.
got
Okay,
go
never
ahead.
mind, never mind.
You sure?
Yeah.
Okay. All right. So you guys have a good one. Be safe, and I'll see you on Thursday.
All right, stay safe.
All right, you do the same. All right, thanks. You do the same. Take care.
You have a great day as well.
Thank you. Appreciate that, sir. You do the same.